Hello, today we'll be doing our NAT presentation. It was done by Lucy and James. So, a brief introduction. NAT is otherwise known as Network Address Translation. The sole reason for its existence is to address the IPv4 address shortage. Even though there are 4.29 billion IPv4 addresses, people ran out of them quite quickly. As the internet grew and grew, no one quite expected it to grow that large, so they didn't create an infinite amount of addresses like they would in IPv6 later on. So how did they keep moving forward with IPv4 with no more available IP addresses? Well, the solution was network address translation. So why do we use NAT? The main reason is to help with the limited number of addresses IPv4 had at the time, as mentioned previously. And this isn't a solution, as it's more of a stall, as we're just trying to create time for future IPv versions to address this issue. And its goal was to limit the amount of IP addresses used by any individual. You would gain private IP addresses rather than public. And the switch to IPv6 is not with the snap of a finger, and it will take time before we have essentially infinite IP addresses with the new system. So how did we even run out of addresses in the first place? So we realized early on that there was a limited IP addresses, so private IP addresses were set aside for this exact purpose. So these addresses are not routable across the internet, and they're only contained internally. These are called RFC 1918 private IPv4 addresses. And the first class A is 10.000 to 10.255.255.255. Class B falls in 172.16.0.0 all the way to 172.21.255.255. And the final Class C is all the way from 198.168.0.0 all the way to 192.168.255.255. And so this is just a small group of addresses that can be used unlimited times while on an internal network, but nothing can be publicly routed to these addresses. These addresses will result in absolutely nothing if you try to access them from the public. So how does NAT even work? In the most simple terms, it's a process of making private IP addresses readable to the World Wide Web. So it starts out with the source address. In this case, it will be 10.0.0.1, and its destination will be a server. In this case, it's 200-100-10-1. For this case, we will pretend the source address will be the computer the viewer is watching the video on, and the server will be the Kaltura site it retrieved the information from. So, the request to initially receive the information from Kaltura is passed through the router, but the router notices that you cannot route out a 10.0.01 address since it falls under Class A of the private addresses. The router will then perform a network address translation to translate the source's address to a usable one. It does this by replacing the private address with the router's address, which in this case is 150.150.0.1. Now, the viewer's computer can finally request the data from Kaltura, and the same process will now happen in reverse. Kaltura will then send the information to the router as the source address now, which is set to 200.100.1.1, and the router will then become the destination address. And once it reaches the router, it will change the destination address from the router to the private address on your computer 10.0.0.1. The packet will then reach its destination on your computer with the voice you are hearing currently. So that is essentially how NAT works.
Hey, so I'm Lucy, and so there are basically three overarching types of NATs. So these types are overload NAT, dynamic NAT, and a static NAT. Next slide. So the most basic type of NAT is basic or static, and it basically maps one unregistered/private IP address to one registered/global/public IP address. So this is just a 1-to-1 scale. It's really not anything special. And yeah, next slide. So dynamic NAT is a little bit more complicated. This is a many-to-one mapping of private IP addresses. So you can have almost infinite private devices on your network, and then they're all going to be assigned one public IP address. But that's an oversimplification of it. There are different types of dynamic NAT addressing, which include symmetric and port restricted, but those are also subtypes of port address translation or source NAT. And then there are also inbound versus outbound NAT, and that is more subtypes of directly dynamic NAT. So the source address, the inbound NAT will translate the source address, whereas the outbound NAT will translate the destination address first. So that's basic. So the inbound is basically a household having one public IP, which is where that is going. Again, basically infinite addresses on your private network, and then you get one public IP address, versus allowing external users access to a server on a private network, like a sort of internet email. So if you were outside of that network and you wanted to access that from home and it was a work address, then you would use outbound NAT to get that. But outbound NAT is a little bit more flexible, because rather than be confined to just that source address and destination address pair, it works with things like domain name servers and other things to make it just a little bit more flexible for more than one situation. Next slide. And then the last type is port address translation, also known as overload NAT, also known as source NAT. So this will use port numbers to translate addresses. It'll map multiple unregistered / local IP addresses into one registered / global IP address, while differentiating between those private addresses using port numbers. So that way no one device on your private network will have the same address, because it will be differentiated by port numbers. Next slide. So as James said, NAT is honestly just a stopgap solution. It is not a real solution. That will come with IPv6, which will render NAT obsolete. But again, that's an oversimplification. There are multiple dynamics at play. Next slide. So there are other issues with IPv4, not just the fact that it has a very limited number of addresses, allowing less than one address per person on the planet right now. So another issue with it is that it is old. IPv4 was invented in 1983, meaning it is just simply not up to today's security threats. It is very vulnerable to hackers and viruses and malware and so many other cybersecurity threats. Next slide. And then IPv6 has been heralded so far as this, we're getting rid of NAT, but it presents its own problems. One of these is the user cost. IPv6 can't be run on an IPv4 machine, which means that you have to buy another machine that can handle IPv6. And that costs money and time, and most people honestly don't want to do that yet. So until they have to, it's a very, very slow transition. Next slide. So we made a little lab for this. It's fairly simple in my opinion, honestly. It's not super complicated, but I will walk you through the directions. So at the top, you put your name in. Okay.
So for the instructions, you'll be assigned 3 addresses: a private address, a destination, and a source address. Your job is to assign them to the correct spot according to what a router would do for network address translation. This means translating the private IP address into the source address, requesting and receiving the information, and sending it back to the private IP address. The first is done for you as an example. So as you can see, just the example problem, Will's Xbox has this private IP address, and its destination address will be this one. And his router is obviously a third separate one. So what happens here is will have an old value and a new value. So Will's Xbox for the source IP address is technically correct, but as we learned earlier, we cannot send it out yet until it has a proper source IP address. So when it goes to the router, it then becomes that router's address, and the destination address does not change. And then the same thing will happen when it comes back in. The source address doesn't change because it obviously stays the same, but then the router's address will become the the private address. And so we just have a few little example problems for you. Once you do the first one, you'll get the hang of it. But this is a good practice of what network address translation does and a few ways to practice it. Thank you very much for watching.